Hello everyone, I'm Mrs Jennison and I'm an Associate Director for Outward Grange Academies Trust. Welcome to our lesson. Today we are looking at the pH scale and indicators. This is a part of the Fizz and Pop topic. Our challenge for today's lesson is to be able to describe the pH scale. Our aspire is to be able to identify acids and alkalis by using indicators. Before we start, it could be a good idea for you to have your planner with you, as there is a copy of the pH scale inside of it. It would also be a really good time to turn off your notifications so that you're not being distracted throughout the lesson, and it'd be good to have a piece of paper and a pen so that you can work through the activities in the video with us. Now, we use a car indicator to show which way we are going. We use universal indicator to measure pH. The pH tells us how acidic or how alkaline a substance is. If something is neutral, it is not acid or alkali. What can you think of that is neutral? You're probably thinking of drinking water, as that's a common neutral substance. The pH is an indicator of how acidic or alkaline a substance is. Universal indicator changes colour based on the pH of a substance. So if it has a low pH, 0 to 6, it is an acid, and that is indicated by a red, orange or yellow colour change. pH 7 indicates a neutral substance, and that is a green colour change. A pH of 8 to 14 indicates an alkali substance, and that is a blue or purple colour change. Now that we've gone through some basic information about indicators, acids and alkalis, I'd like you to have a go at answering the 3 questions on the screen. What is the name of the type of indicator we can use to test if liquids are acids or alkalis? What colour do acids show, and what colour do alkalis show? The liquid we can use is universal indicator. Acids show a red colour and alkalis show a purple or blue colour. So on the screen now you can see the pH scale. Some diagrams, like the one on the screen, show it going from 1 to 14. Other diagrams may show it going from 0 to 14. Now, the colour change of universal indicator would be cross-checked with this scale so that you can code that colour to a numerical value for the pH. Now, as you can see on here, a pH of 7 would be a neutral substance, or a substance that is neither acid nor alkali. As we go from 7 towards 1, as the number gets lower, the pH dictates an actually stronger acid. So a low value means a very strong acid. A higher value of like 6 or 5 would be a weaker acid. As the number increases from 7, the substances get increasingly alkali. So 14 would be a very strong alkali, whereas 8 or 9 would be a weaker alkali. We've gone through that and added a little bit more to what we said earlier. I'm just going to give you a little bit of time to have a go at answering the 7 questions on the screen. Test the pH of an unknown solution. You would add universal indicator and convert the colour seen to a pH. The pH of a strong acid would be 1 or 0. The pH of a weak acid would be 6. You could have said 5. The pH of a strong alkali would be 14. And a weak alkali would be 8. The pH neutral is 7. And a substance with a neutral pH would be water. So what is the connection between the 3 items on the screen? We've got some lemons and limes, we've got vinegar, and we've also got nettles. Well, the connection is that these are actually all acidic substances. So acids aren't just what you would see as chemicals in a glass bottle in a classroom. There is acids in your homes that you sometimes may use every single day. Now, just a reminder of the pH scale. If you have your planner, it could be a good idea to have it open on the pH scale so that you can refer to it through the rest of this lesson. So I'm just going to insert a summary video on acids and alkalis and also bases before we move on to other indicators.
In today's video, we're going to look at the pH scale and see what acids and alkalis are. pH is really just a measure of how acidic or alkaline a solution is. and it's measured on a scale from 0 to 14, with low numbers being most acidic and high numbers being most alkaline. And if the substance is neutral, like pure water, then the pH would be 7, which is neither acidic nor alkaline. To give you some idea of what all of this means, the acid in your stomach, which helps you to kill bacteria, has a pH of around 2, while acid rain is around pH 4. Then for alkalis, washing up liquid has a pH of around 9, and the bleach we use to clean bathrooms has a pH of around 12. Be aware though, you don't have to remember these specific examples, they're just to give you some context. Now we can measure pH in a couple of different ways. One is to use some kind of indicator, which are a group of chemical dyes that change colour depending on the pH. And different indicators will change colour at different pHs. Some indicators contain a mixture of these different dyes though, so their colour will slowly change across a wide range of pHs. So we often refer to them as wide range indicators. The most common example is universal indicator, which gives the colours we've shown on our pH scale here, ranging from deep red at a very low and acidic pH, to yellow, green, and then bluey purple as we increase the pH and it becomes more alkaline. The other way to measure pH is to use a pH probe connected to a pH meter. By dipping the probe into a solution, we can electronically measure the pH and get a numerical reading on the meter. The benefit of the probe compared to an indicator is that it can be much more accurate and precise, because it doesn't involve humans guessing shades or particular colours. And as a general rule, measurements that remove the need for human judgment are going to be more reliable. The next thing we need to look at is what exactly makes something an acid. You can define an acid as any substance that forms aqueous solutions with a pH of less than 7. And the reason for this is that acids release hydrogen ions in water, which make the solution acidic. On the other side of the scale, we have bases, which we define as any substance with a pH greater than 7. Meanwhile, alkalis, which we mentioned before, are actually a subgroup of bases that are soluble in water. So we would say that an alkali is a base that dissolves in water to form a solution with a pH greater than 7. And these alkalis form OH- ions in water, which we call hydroxide ions.
Now it's time for us to have a little look at some other examples of indicators. Now an indicator is a substance that will change colour based on the pH of a substance it has been placed in. Now up until this point we have referred to universal indicator, but there are actually many different examples of indicators and some of them are natural. So in the image on the screen at the moment you can see some examples of natural indicators. So these are substances that will change colour if you place them into an acid or an alkali. Now the one at the bottom, red cabbage, is actually one I've made for the next video on this topic and done some experiments with at home. And that is something I definitely recommend for you to have a go at making red cabbage indicator and identifying whether some of your household substances are acids or alkalis. Now, just like universal indicator, you would have to cross-check that colour change with a scale so that you can convert that pH into a number. There are some other indicators as well that are more chemical and can be used in a lab. We have our universal indicator, which gives us a wide range of colour changes, but some indicators only indicate whether it is an acid or an alkali. For example, phenolphthalein will be pink in alkali conditions and it will be colourless in acidic conditions. Methyl orange is red in acidic conditions and it will be yellow in alkali conditions. And there are a few others on the screen on the image at the moment. Now, universal indicator is actually a mixture of dyes, which is why it gets that broad range. And it's really great if you want to know the specific pH for substance, but it is quite subjective as you are matching colours, and that does sometimes get quite difficult, especially when there's very subtle colour changes. For example, different shades of blue or different shades of green. Sometimes if you just want to know whether something is acid or alkali, you're more likely to use something like phenolphthalein or even litmus. Litmus is blue when it is in alkali and it is red when it is in acid. You can get red litmus, that stays red in acid or turns blue in alkali, and then you can get blue litmus, but the colour change is always the same. The common indicators you would use in a lab are indicators such as litmus, methyl orange, phenolphthalein, and then if we do need to know the pH, we would use universal indicator. Or sometimes we would use a pH probe, which is slightly more accurate. Now, a little quiz based on what we've just discussed about indicators. I've put some questions on the screen. I just want you to tell me whether that substance would be an acid or an alkali. So the first one would be an alkali, and litmus turns red, it is in an acid. Phenolphthalein turns pink for an alkali, methyl orange turns red for an acid, and universal indicator turns yellow for an acid. And remember, the last one would actually be a weak acid. So in another example, I've given you the results of a student's experiment where they've identified 5 unknown substances and added universal indicator to note the colour change. What I'd like you to do is, using what we've learned about the pH scale so far and universal indicator, I would like you to tell me whether that substance is an acid, alkali or neutral. And then I'd like you to match that to a pH value. So for the first one, we've got a neutral substance of pH 7. Substance B is an acid with a pH of 6. Substance C is an acid again, but it's a strong acid this time, so it's got a pH of 1. Substance D is alkaline of a pH of around 10. And substance E is an alkaline again, a strong alkaline with a pH of 14. Okay, so now it is time for you to apply what we have learned so far. I want you to imagine that a teacher finds a spillage on a lab desk, and next to the spillage there are 2 bottles, hydrochloric acid and distilled water. Now you can see those bottles on the screen at the moment and any relevant hazard labels. How could the teacher test the spillage to identify the substance? And then I'd like you to try and explain why it is important that the substance is identified before it is cleaned up. Now remember, when you are explaining, you are saying why something must happen, and it is worth using the connective because. So first of all, the teacher could test the spillage by using an indicator. Now, any of the examples that we spoke about earlier would have been acceptable for this, but I've used universal indicator in my answer because universal indicator would be red with the acid, but it would be green with the water. So it would be really easy to identify which one is the acid and which one is neutral. Now then, it's important because the acid is corrosive. As you can see, it's got a quite serious hazard symbol on that bottle. So there should probably be gloves put on before cleaning up that spillage, should it be acid. Whereas if it was water, water's low hazard, so that precaution wouldn't be needed. And remember, this is an example where it's a science teacher finding that spillage on a lab desk. This is not an example of a spillage in any other context. So in this one, it could be quite dangerous, that acid, so they do have to be very safe. Now, we already mentioned earlier that there are some acids and alkalis that we may use in real life. Some of them are found in foods. So berries and citrus fruits are actually acidic. They contain an acid called citric acid. Bicarbonate of soda and chocolate are alkaline substances. In our body uses acids and alkalis. There is acidic stomach juices, and they actually contain hydrochloric acid, and pancreatic juices are actually alkaline. We also use acids and alkalis for cleaning products. So a lot of cleaning products contain ammonia, which makes them alkaline, but some other cleaning products may contain vinegar. They mainly contain ethanoic acid, so things like glass cleaner, which does smell slightly like vinegar, that would be an acidic chemical. Now, here's an example of an experiment that I did at home. This is part 1 of the experiment. So I bought some universal indicator. I actually bought it online. It was very cheap. It was for people to test their fish tanks. And I had 6 substances that I got from my house, and I labelled them 1 to 6. And I did put in a table, which you'll see in a little bit, what each of those substances were. I added a very small piece of the indicator paper to each of the substances and made a note of the colour change. And here are the substances I used. So substance 1 was lime juice, then 2 was water, 3 was Dettol soap, 4 was fairy liquid, 5 was white vinegar, 6 was rubbing alcohol, and 7 was bleach. I've given you a partially completed version of my results table, and what I'd like you to do is I'd like you to complete the blank sections to the best that you can. The lime juice is an acid. The water would turn green as it's a neutral substance. The Dettol soap was an alkali, as was the fairy liquid. White vinegar, which is that ethanoic acid I discussed earlier, was an acid. Now rubbing alcohol, again, neutral, so it would be a green colour change and a pH of 7, and the bleach was alkali. It was a very strong alkali actually, and it actually removed the colour from the universal indicator paper when it was left in for a while. Now remember that these are subjective and they are based on matching the colour of the paper to a scale. So there was actually a coloured card insert which had a scale on it, which means actually these may not be very accurate, and it would have been much more accurate to use a pH probe, but I don't have one at home unfortunately. Now I'm going to insert a little video here. It's a song and I absolutely love it. It's brilliant and I hope you enjoy it.
Acids and bases have two different faces, two different personalities, and you gotta find out what they're all about if you wanna learn chemistry. Now the first thing you gotta get straight in your head: acids turn blue litmus paper to red. They react with metals with awesome power. They neutralize bases and taste very sour. Bases are different from acids, it's true. Bases turn red litmus paper to blue. They neutralize acids, feel slippery on skin. They taste sort of bitter and they're called alkaline. Acids and bases have two different faces, two different personalities, and you gotta find out what they're all about if you wanna learn chemistry. Well, there's even more to this wonderful tale, something we call a pH scale. It numbers from 0 up to 14. Those are powers of 10, if you know what I mean. When the pH is 7, then it's a case where the sample is neither acid nor base. But less than 7, it's an acid, we say. More than 7, it's a base all the way. Acids and bases have two different faces, two different personalities, and you gotta find out what they're all about if you want to learn chemistry. Well, acids and bases, now why should you care? 'Cause acids and bases are everywhere. You put them on salads and they get in the rain. They settle your tummy and clean out your drain. So the next time you're sitting under some shade and you're sipping a glass full of real lemonade, you'll notice the sour taste and think in your head, I bet it turns blue litmus paper to red. Acids and bases have two different faces, two different personalities, and you gotta find out what they're all about if you wanna learn chemistry.
That's everything for me in this lesson, and I will see you soon.